I am the student of MIT Academy of Engineering, and under the course of Electronic Circuits and Application, we are having a group project titled Light Activated Switch using LDR and opamp comparator. So I am Ritesh Asole from A Division with PRN 202301060014, batch A4. I am having Keshav with me. So our project is light activated switch using LDR and opamp comparator. So our aim is to design and simulate the light activated switch circuit using opamp comparator and LDR. When we the real world application, it includes the automatic street lighting and where lights turn on or off based on the ambient light level. So this is one of the application that we are using, or we can say that can be the one of the application of our project. So the main objective is to know about the op-amp functioning and know about the LDR functioning. So we are going to know about how these two components work, and also to the simulation software that we have used, that how we have used, and all about that we got to know about it. So that is one of the objective of us. When we see the expected outcome, as I said, we are going to design and simulated the circuit, which includes op-amp and LDR. So we will be knowing the information of regarding it. When we think of the procedure, we can say the first thing is the working of op-amp comparator circuit. So there is an op-amp which is having the two terminal, that is non-inverting terminal and the inverting terminal. So we can say that op-amp operates as a comparator, comparing voltages at its non-inverting and inverting terminals to switch its output. Uh, then the second is LDR, that is light dependent resistor or potentiometer. So the functioning is, we can say that the variable resistor, that is potentiometer, allows us to set the reference voltage at the inverting terminal of the op-amp, and by setting this value we are able to determine the light level at which the LED will turn on or off. So the second is designing the circuit. So first of all, we are doing that on the Tinkercad software, where this data that we have collected after doing the simulation, these are the components that we have used on Tinkercad. So which includes the 741 IC op-amp, photoresistor, potentiometer, resistor, red LED, then power supply, then voltage multimeter. So these are the component that we have used with these particular values. Power supply with 12 volt, potentiometer with 250 kilo ohm, LDR with 1 kilo ohm. And this is the basic layout that we have got from the Tinkercad software after doing the simulation. So when we have did the simulation, we get its printout that how our simulation looks like as a layout or as a circuit. So here the you can see, here you can see there is a power supply, then there is a resistor, then this is the LDR, that is light dependent resistor. You can see that light is emitting on this resistor, and because of which the functioning can happen. Secondly, that is this is the potentiometer, which is the variable resistor acting as the variable resistor, and this is power supply, this is the ground connection, and this all connection are here with to the inverting terminal and the non-inverting terminal of the op-amp 741. And at last there is the LED as a result or as an output. We will be getting to know about it, and this is the resistor. So finally this is the overall circuit, and we will be able to have the switching of the LED, or we can say the light activated switch, what we want, whatever we want, that has been achieved from that, we can say. Now the further functioning of the circuit, or we can say the working of the circuit, and the rest of the part of the project will be explained by Keshav. So I will invite him.
Hello, myself Keshwar Ansarji, PRN 202301070086. I am here to explain working principle of our project. Uh, L- uh, Light activated switch using LDR and opamp. So, circuit operation discuss the relationship between light levels and the LDR resistance. In low light, the LDR resistance is high, leading to higher voltage at the non-inverting terminal. Conversely, in a bright light, the resistance drops, reducing the voltage. Explain how the op-amp compares this voltage with the reference voltage set by potentiometer. Detail Detail how the output of op-amp switches based on these comparisons. Where the voltage at the non-inverting terminal exceeds that of the inverting terminal, the output goes high, turning the LED on. When the inverting terminal voltage is higher, the output goes low and the LED turns off. So next point is a simulation setup. Simulation environment introduced Tinkercad, explaining that it is a user-friendly platform for simulating electronic circuits. Setting up the setting up the circuits demonstrate the process of building the circuit in Tinkercad, showing how each component is placed and connected according to schematic. Emphasize the importance of the voltage divider configuration formed by the LDR and potentiometer, explaining how it generates a variable input voltage for op-amp. Simulating light conditions, changing light levels show how to adjust simulated light levels within Tinkercad. You can do this by using the light intensity settings available in a software, explaining that as you change the light intensity, the resistance of LDR will change, which in terms of in turn alters the voltage at non-inverting terminal of the op-amp. So output behavior is to illustrate the changes in LED state as light levels vary. Highlight the LED illuminates when the input voltage exceeds the threshold and turns off when it drops below the threshold. Use the multimeter in a Tinkercad to show the real time voltage readings for the both input from the LDR and output from op-amp. Results and analysis show simulation results. Display the screen. We have displayed the screenshots or live demonstration of the result during the simulation. You could show a side-by-side comparison of the input voltage from the LDR and the output voltage from op-amp. So at the end, we can draw a conclusion. So the circuit successfully demonstrates a light activated switch using an op-amp comparator, highlighting its responsiveness to the light levels and how it functions as a level detector. Practical applications briefly mention real-world applications such as automatic lighting system in homes or streetlights, where such a circuits can be beneficial. Encouragement invite viewers to experiment with the circuit design and explore various combinations configurations to see how they affect performance. Thank you.
Thank you for listening our views on op-amp and LDR based switching circuit, uh, that is light activated switch circuit. So thank you. Thank you for listening our views on op-amp and LDR based switching circuit, uh, that is light activated switch circuit. So thank you.
How it functions as a level detector. Practical applications briefly mention real-world applications such as automatic lighting system in homes or streetlights, where such circuits can be beneficial. Encouragement invite viewers to experiment with the circuit design and explore various combinations configurations to see how they affect performance. Thank you.
Thank you so much. Thank you.